Greetings, fellow material beings. Tonight I introduce you to chemistry by explaining the basics of atoms, the building blocks of the universe. Atom may mean indivisible, but they're made of smaller parts. I guess quarks, electrons, and so on aren't really matter, so we can say atoms are the smallest piece of matter there is. Each element in the periodic table corresponds to a different kind of atom. The top left is the smallest one, hydrogen, so the bottom right is the heaviest element. We don't know much about the elements there because they're so unstable that they turn back into smaller atoms super quick. Obviously, you can't find those in nature. Well, maybe in some stars or something, but we can't get there. So, Anyway, all these atoms can only be seen in the lab. What's wrong with you, Technetium? Let's have heavier elements or stable. Sorry, that was a bit rude. So, the weight of an atom is determined mostly by what's in its nucleus, its core if you will. It's made up of protons and neutrons. These are almost 2,000 times the mass of the electrons that hang around. By the way, electrons don't orbit the atoms like, say, planets orbit the sun. They're a certain distance away, but they could be anywhere on that layer at any given moment, and they're real far from the nucleus. You can't even show it to scale on a graph. Okay, back to the core. The neutrons are there to help protons stick together. Basically, protons don't like being together, but they like neutrons, so the neutrons hide protons from each other. The number of neutrons in an atom can vary, but each has a preferred stable number. Like for hydrogen, it doesn't need neutrons, since it has only one proton. But sometimes hydrogen has a neutron. You'd call that deuterium. We say deuterium is an isotope of hydrogen. There can be more neutrons in hydrogen, but that becomes super rare because of instability. You might have heard of other isotopes, like carbon-14, which has 6 protons and 8 neutrons, instead of the more stable 6 or 7 neutrons. So, carbon-12 and 13 are the most stable isotopes. Okay, here comes the good stuff. Protons. I mentioned them a fair bit, but what do they do? Oh, only the most important part, making atoms what they are. Seriously, remember how I said hydrogen has only one proton? If it were 2, that would be helium. 3 protons, lithium. 4, beryllium, baby. That's the most fundamental difference between elements. How many protons are in the nucleus? Think about it. This ball of copper, say it is pure, has atoms with 29 protons in each. This ball of zinc has atoms with 30 protons. And they both have different properties. Am I weird for thinking this is mind-blowing? Anyway, I've barely touched on electrons, and they're a pretty important part of atom behavior. But I'd rather keep these videos short, so it'll have to wait. Well, I'll see you next time. Bye!